Hey there. Today we are looking at the graphs of exponential and log functions. So we've spent a couple days talking about them algebraically. Let's look at what's going on with their graphs. Let's take a look at exponentials first. And what we're going to do is we're going to look at just some of the parent functions. And by parent functions, there's nothing going on other than taking a base to a power. And we consider the true parent function to have a 2 raised to the x power. So if you were to fill out a table of values, which we want to start with, but then we want to start just kind of remembering it so that we can do a quick graph. You're going to take this to the negative second power. Squaring it will make it a 4, but the negative will move it to the denominator. So that's going to end up being a 1/4. If you take it to the negative first, then it's just to the first power, but it shifts to the denominator, so you have a 1/2. Anything raised to the 0 power is 1, 2 to the first, 2 to the second, 2 to the third. All right, so if we graph these ordered pairs, so -2 up a 4th and -1 up a half, not much difference there, hard for me to graph it, over 0 up 1, 1, 2, 2, 4, and 3, 8. And then after that, it'll be off of my graph. But this is the general shape of an exponential function. It starts off low, and then at some point, it just starts shooting up very rapidly. Now, some things to consider on this. Let's talk about the domain, first of all. The domain will go forever left and forever right. The range, however, has a bottom limit to it. You can see it here. It's actually a horizontal asymptote. And so this horizontal asymptote needs to be part of your graph. In this case, it's at 0, so that would make the range go from 0 to infinity, but since there's an asymptote at 0, we would put a parenthesis on that. Now, they don't really have a vertex, but they do have this key point that we sort of track as we start shifting this function around. And any exponential function in this format, again, as long as you don't have any special extra stuff going on, adding or subtracting, moving it around, it will always pass through the point right here, 0, 1. And so it's not called the vertex, but that's the point that we're going to sort of track to move this graph around. It will also always have this horizontal asymptote at 0. Now, let's see what happens as we start to change some things on this. What would happen if we change the base to a 3? Well, the general shape still looks the same, but it does kind of change some values. 3 to the negative second, that would be a 1/9. To the negative first would be a 1/3. 0 is a 1. 3 to the first, 3 to the second, and 3 to the third would be way off of your graph. But so in general, it's going to have this same shape. It's going to come swooping up here. It's still going to cross right here at 0, 1. It's still going to level off, and you're still going to have this horizontal asymptote. What really changes that we want to track is how quickly this shoots upward now. So that's where these 2 points come into play. I would be plotting 1, 3, and then I'd be plotting 2, 9, and then I would be off the graph. But it does shoot up a little bit more quickly because this base gets steeper or larger. And so as this base value gets bigger, this it crosses right here at 1 and then shoots up a little bit faster. Now, what happens if your base is a fraction? Now what happens with your when you put in a negative, it's going to pop it upward. So popping it upward is going to make that -2 take the 3 up and square it. Take the 3 up to the first power. Anything to the 0 is 1. 1/3 to the first. 1/3 to the second would be a 1/9, and then a 1/27. Imagine that graph. It's still going to cross right here. It's still going to have this horizontal asymptote. But now what happens is the -2 is taking us way up here to 9. The -1 is taking us to a 3. And over to the right side is where we start leveling off. If you look at this, oh, I kind of missed my dots, sorry. It's a nice reflection over the y-axis. You can see that it is reflected. The reason that it has reflected is this 1/3 could really be written as a 3 to the -1st to the x power, which would be 3 to the -x. And if you put a negative in front of your x, that's going to be a horizontal reflection, if you'll remember that from way back when we were doing all the transformations. And so this, anytime you have a fraction here, it's really just a reflection of if it wasn't the fraction. Now, what changes also is the fact that this is growing exponentially, whereas this one is decaying exponentially. If this value is less than 1, you actually have an exponential decay graph. If you can think through this, the 3, if you could just keep track of the 3 and know that it does this, and then when you see the 1/3, just know that it does it backwards. And you don't have to keep track of all the table values every time. Once you understand what those parent graphs look like, then we're going to start doing transformations on that. So let's just talk through some things. This is the format. It looks definitely messier than what we were just doing, but it should have all those same patterns of transformations. This A value right here, this is a vertical stretch. Now this is going to stretch. It's still going to cross at 0, 1, and then it's going to stretch from there. But what if it is negative? Well, if it is negative, it is a vertical reflection. So it's going to flip it upside down. That is not what we just got done doing. We did a horizontal reflection. A vertical reflection, if this is the original, the reflection is going to look like this. Still, both of them will have this horizontal asymptote. All right, if the C is negative, that's what we just got done doing. And I kind of already talked about that. 2 to the -x, you could also look at it as a 1/2, but those both are horizontal reflections. And you'll see them both ways. They do the same thing. So the original is exponential growth. The reflection is exponential decay. Both have the horizontal asymptote right here. Okay, so let's talk through these. I'm not going to necessarily write something on every one of these, but let's at least talk through it. Let's look at some different transformations. I'm going to just start off real quickly, and you can do this as well. I'm going to go ahead and just put in the parent graph on all of these. And then we'll just talk about all of them together. I think it helps before you start doing transformations to have an idea of what you think the end result is going to look like. So on each one of these, okay, so the negative in front, that is a vertical thing. Remember, a negative on the x, that's a horizontal thing. So this is a vertical reflection, horizontal reflection. So a vertical reflection would flip upside down like that over the x-axis. A horizontal is going to flip over the y-axis. Remember, though, that a 2 to the -x could also be written like a 1/2 to the x. Okay, next thing I want to look at is what happens as this changes. Okay, well, as that gets to be a bigger number, how quickly your graph increases is what starts to change. So if what I have is a 2 to the x, this will look like a 4 to the x. It'll shoot up more quickly. Okay, so this next one, not only is it going to shoot up more quickly, it's also going to be that horizontal reflection. So my exponential growth is going to turn into exponential decay but it's going to be steeper also. So it's going to be something like that. Last one. All right, so this one has a vertical stretch. That's what that 3 is. That's a vertical stretch. It's like the A value up here. It's going to be a vertical stretch. So it's going to stretch everything vertically, going to go 3 times farther off of where it is on the parent graph. So what that's going to mean is everything's going to kind of stretch upward. So this key point right here is actually, instead of being up 1, is now going to be up 3. So it's going to go there, and everything's going to come up, stretch off of that axis. So it's going to kind of do something like this. Now, I'm probably honestly not going to do a lot of the A values on these. We're going to focus more on those reflections and what changes with this base. Now, as I mentioned, you're going to have to know those key tables. So both of these you can see have a base of 3. So in your mind, you're going to have to remember that whole, all right, if I had just the parent graph y equals 3 to the x, it's exponential growth. I'm not too worried about these low fractional numbers. I know it's going to cross at 1, and then really it's this piece. I want to get these points good. So a 3 to the first is going to be a 3 to the second is a 9, and I am off my graph. Okay, so looking at this first one, it is just the parent graph, but this x plus 1, sometimes they'll put it in parentheses, sometimes they won't, but it is tucked in there with the x. It is going to be a horizontal. I'm going to do the opposite. I'm going to take my graph and go left 3. So that going left 3 is not going to adjust my parent, or I mean my horizontal asymptote. I am still going to have a horizontal asymptote right here. What is going to change is this key point. So these are kind of the two things we start with, is where's that asymptote, where's that key point going to be? And that key point is going to move left 1. So it is now right here. Now that means everything's going to move left 1. So I don't know how much of this you're going to want to like start with the original and have to redo everything, but my 1 3 point, my 2 9 point, those points are moving left 1. Let me change the color for the new ones, I guess. I'll put that red. This is going to go left 1. This is going to go left 1. Horizontal asymptote still right here. So really what I want is my red graph. That's the shift, the horizontal shift from the parent graph. All right, our next example, a lot trickier, a lot more going on here. Well, I say a lot, maybe not a lot. All right, this right here is going to be a vertical reflection. And then this is going to be -2. That's kind of like out at the end. It's going to take it down 2. So I'm going to go ahead and throw in the parent graph would look like this with a key point right here. And since it's a 3, I've got a 1 3 and a 2 9. Now, again, I like to think about what's my end result going to look like. If this is the parent graph that I'm dealing with, what is going to happen? Well, it's going to vertically reflect, and it's going to go down too. A vertical reflection is like this, but then it's going to go down too. So this one right here is the one I think I'm going to have for my final result. What I'm going to do is take each of these points and do what I just said. It's going to vertically reflect. So now I'm here, down 1 right here. Vertically reflect and then down 1. Vertically reflect and then down 1. And the down 1 is actually going to move my horizontal asymptote as well. And so here's what my graph looks like. Let's talk about domain and range for these. All right, domain is how far left and how far right. So it goes, I'm looking at the red here, right? That was my end result, negative infinity to positive infinity. What does have a limitation is the range. It has to do with that asymptote. So the lowest it ever went was 0 up to infinity, parenthesis, because of the asymptote. Next one, domain, goes forever left, forever right. But the range, now this one's different. The lowest it ever goes is negative infinity. The highest it gets is up to that asymptote at 1. Oh, sorry, at negative 1. There we go. So just doing kind of the same thing here. Now I have a 3 to the x minus 4 and a plus 5. So if I'm going to go ahead and put in the parent graph, crosses right here, has a horizontal asymptote, 1, 3, 2, 9. Okay, so I can, in my head, whether you have to necessarily graph it, I'd like to think you don't have to graph it, but in your head, you at least know this is what's going on. I'm going to take those away, undo that, but no, keep the points there maybe for myself, because each one of those points then is going to go right 4, up 5. Right 4, up 5. Now the next one is going to be way off my grasp. I'm not even going to worry about it. But the right 4 does not affect the asymptote. The up 5 does, though. So the asymptote is no longer at 0, but it is now right here at 5. And it's just going to take graph. And the key point now, because the shift is right here, and that's sort of the spot where it starts to turn on us. All right, I'm going to change it up on us. The next one has a base of 2. That doesn't change where my asymptote is. It's still here. My key point still at 1 here. But now it's a 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. It gets me an extra point in there. Again, this is what the parent graph looks like, but I'm hoping that we can just use the points, so I'm taking that back off. Now, what do I do with all those points? Well, the negative up here is a horizontal, it's with the x, so it's a horizontal thing. It's going to reflect it horizontally, and then the plus 4 takes it up 4. So I'm taking this point right here, I'm going to reflect it horizontally, which doesn't do anything, but I'm going to take it up 4. So plot that point. Next one, reflect horizontally, so this point is going to end up here, and then up 4. Next one, reflect horizontally, up 4, up here somewhere. The up 4 is taking the asymptote up 4. And here's my graph. Remember that having a negative on your exponent or writing this as a fraction changes your exponential growth into exponential decay. Let's see, what am I forgetting here before I move on? I guess, what is my expectation on your homework? I think until you get a good handle on it, you should probably have these blue dots on there. But if you're super good at this and think you can do it without, that's okay. The bare minimum is that I see the red asymptote and the red graph. That's the end result. But the asymptote is part of what I'm looking for, so make sure you have that. Let's go ahead and do domain and range. All right, it goes forever left. I'm looking at the red. Maybe I should write in red so you remember that. Forever left, it goes forever right. The limitation on the range is coming from the asymptote. The lowest it gets is 5. Highest it gets, infinity. Next one. Again, goes forever left, goes forever right. The range, the lowest it gets is a 4 to infinity. Now, ideally, I'm hoping you're catching on that every time our domain has been negative infinity to infinity. Every time. That's going to be the case. Every time the domain for exponentials, regardless of what sort of reflection might happen on it, your domain will stay negative infinity to infinity. And your range is going to get limited by the asymptote. All right, one more page of these exponentials. I'm changing it up again. I'm making this base be different. So you have to keep in mind what that is going to look like. So I guess over here, I'll do the 4. And again, I know I'm going to have a horizontal asymptote. I know it's going to cross at 1. And then what happens? How quickly is it shooting up? Well, if I put in a 1, I'm going to already be at 4. And if I put in a 2, I'm going to be at 16. And again, this is just like the parent with a base of 4. So you're not going to really get very many dots here plotted. So I'll go ahead and plot those. So I know it's crossing right here. 1, 4, 2, 16 is way off the graph, has a horizontal asymptote right here. Shoots upward very quickly. All right, let's do what we got to do here. It looks like we are going to go left 3, down 2. Every point goes left 3, down 2. And the horizontal asymptote, left 3, down 2. All right, and then you just sketch that graph in there. All right, last one. I'm going to change the base to a 1/2. Okay, 1/2 is my clue. This is exponential decay. So what I usually feel like is going to be like right here, thinking base 2 because of the 2 in there. 1, 2, 2, 4, 3, 8. All right, but it's exponential decay. So those points are really all reflected over to here and here and here. This is exponential decay, actually. This point won't reflect, won't change where the asymptote is. But I also have to take everything and now move it down 5. So I'm taking my green dots and going down 5. And that's taking the asymptote down 5 also. Notice on both of my graphs, the domain is still negative infinity to infinity. The range is going to be restricted by the horizontal asymptote. All right, best case scenario, you have your homework worksheet already printed off or you picked it up and you can work on that. What I would highly recommend is if you haven't done those things, do it now. You need to practice these exponentials right now before I blow your mind with the logarithmic graphs, because it tends to be a lot to wrap your head around all in one day. So it's nice to take a little break and practice exponentials. All right, now that you have practiced exponentials, we're going to do some logarithms. Now, if you will recall that logarithms and exponentials are inverse operations of one another. And inverse operations, if you will recall, swap the x's and the y's. To swap the x's and the y's, think about this with me. This is a y equals 2 to the x. So when x is 1, well, you know what? Okay, that doesn't look good. I'm going to fix this. That looks like 2 times x. It's 2 to the x power. I might even, well, heck, I'm just going to go ahead and replace and put that table in that we had several slides ago. I'm going to go ahead and put it here so we can look at it. Okay, so 2 to the negative 2 was 1/4. 2 to the negative 1 was a 1/2. 0, 1. 2 to the first, 2 to the second, 2 to the third. Now, the x's and y's switch on this. And I think I just did a quickie copy paste job on my slide here because the table I've given you here doesn't really match the opportunity we have to just flip-flop these. So here's what I need you to do. I want you just to scribble out what I have given you here. And maybe by now I have your notes fixed. I shouldn't have even put anything there because what I'm going to do now is I'm just going to take this table we do for the exponential with a base 2, and I'm going to flip-flop the x's and y's to do the log function with a base 2. So the negative 2, 1/4, is now going to be a 1/4 negative 2. And then a 1/2 negative 1, a 1, 0, a 4, 2, and an 8, 3. Now let's go plot those points so you can see what happens. Going over a 4th, down 2. Over a 1/2, down 1. Kind of hard to show that. Over 1, up 0. Over 4, up 2. Over 8, up 3. Okay, you can kind of see this happening now. And you know what? Here's the other thing. I'm going to erase this in a second, but remember that these also will reflect over the y equals x line. So if you look at what this would look like, I'm going to throw these in. You can just watch this. I'm going to erase it here in a second. There we go. If we reflect this over the y equals x line, do you see how nicely this is now going to reflect? And it's going to look like this. Shoot off. So instead of shooting up rapidly like exponentials do, logarithms shoot over towards the right rapidly. Okay, so let me undo some things here. All right. Oh, dang it. Well, okay. So what also happens with that, if I'm switching my x's and y's, it switches my horizontal asymptote into a vertical asymptote. I now have a vertical asymptote right here. And then my graph is going to come up this way and shoot off to the right. All right, that is your parent logarithmic graph. So graphs of log graphs always pass through. Now, instead of it crossing through right here, like exponentials, it crosses through right here. So it crosses through the point 1, 0 instead of 0, 1. Remember, x's and y's swap everything. My asymptote no longer at y equals 0. My asymptote is now at x equals 0. Remember how the domain was always negative infinity to infinity? That's now the range, negative infinity to infinity. My graph will go forever left and forever right. I'm sorry, no. My graph will go forever down and forever up, just gradually getting higher and higher. So this time, the range will always be the negative infinity to infinity, and the domain is going to get restricted by the asymptote. The vertical asymptote is going to restrict how far I can go left and right. So in this particular parent graph, I'm going to go from 0 to infinity. And because of the asymptote, we're always having parentheses on these. Okay, so there's your parent graph. Take a look at that. It's always going to look like this right here until we start doing all of our transformations, which is where we're headed. All right, what's going to happen if I change the base? So here I have an example where I changed the base to 5. Okay, so think about this. If it was an exponential, it'd be a 5 to the x. And so I know I'm going to have my key point. I know I'm going to have my vertical asymptote. It's going to be, oops, I'm going to do red because red is always my final color. So red's there. It's going to cross right here. That's going to hold true. As the 5, remember how that made it shoot up more quickly? This is going to make it shoot to the right more quickly. So now if you think about on the exponential, if I put in a 1, I would have gotten a 5. On the log, what that means is if when I put in a 5, I get a 1. So over 5, up 1. So it's just making this graph shoot off to the right more quickly, like that. Okay, so now this is the graph I'm going to use. Look at the next example. What's my graph going to do? It's going to go up 2. So it is not going to change that vertical asymptote, but it's going to take all those points that I just plotted on the left here, and I'm just going to go up 2. So now I'm at here, and instead of at 5, 1, I'm going to end up at 5, 3, and I just draw this graph, come up, and shoot off to the right very quickly. Make sure you're getting your asymptote in all of these graphs, and it really, really helps me if you extend it past so I don't have to search for that. Sometimes your pencil blends in with that axis, and it's hard for me to see. So extend it past so I don't have to be searching for it. All right, let's quick do some domain and range. Remember what I said? The range, always going to be negative infinity to infinity. Doesn't matter what you do with your transformations, we're going to keep it like that. Okay, the domain is going to get restricted by the asymptote. So it looks like I'm going to be, the farthest to the left is 0 to infinity. The next one, still 0 to infinity because the asymptote did not move. All right, what if it's a base 3? Okie doke. Not going to change my asymptote. Still going to be right here. Not going to change my key point. Still going to be right here. What's going to change is how quickly it shoots off to the side. So instead of the last one was a over 5 up 1, this is going to be an over 3 up 1. That might be something you can start to remember. But the 5 only had 1 point. This could have more. Remember, if it was a 3 to the x, if x was 1, that was, so x1 would get me a 3. If x was 2, I would have got a 9. But I'm flip-flopping them because it's an exponential. So that 3, 1, got it. 9, 2, got it. Now sketch that in there. Okay, take this graph, and now we're going to move it left 2. Everything goes left 2. This actually will affect that asymptote. The asymptote will now go left 2. My key point will go left 2. My over 3 up 1 is going to go left 2. And my over 9 up 2 is going to go left 2. And then just sketch that baby in there. All right, range. I don't know why I'm starting with range, just because I want to, because it's always negative infinity to infinity on logarithm graphs. Domain, this one is blocked at 0, but the next one, it went left 2. So now the boundary is negative 2 to infinity. Okay, one more practice slide here. We've got more stuff going on. I've got a negative that's out in front. So that is a vertical reflection. And then I'm going to go right 3. When I start having multiple things happening, I might want to go ahead and plot the parent graph in there just to be on the safe side. This is a base of 2. So it's going to be here, and then 4, 2, and then 8, 3. And it would have this vertical asymptote right here. Okay, let's do all the stuff to it. This says I'm going to reflect it vertically, so it's going to reflect over the x-axis here. So this point won't change. This point will come down. This point will come down. This point will come down. But at the same time, after I reflect it, I'm going to move it right 3. So here I go. First dot doesn't really reflect, but I'm going to go right 3. Next dot, I'm going to reflect it right 3. Reflect, right 3. Reflect, right 3. The reflection does not affect my asymptote, but it is going to move it right 3. If it helps you to understand what's going on, though I feel like this looks pretty obvious. You get enough points in there, you can kind of figure it out. It's when you start using a higher base and you don't have as many points to be checking, you start to lose track of which way it's going. If it helps you to always look at, all right, here's my parent logarithm. If I were to reflect that vertically, it's going to look like this. So it's kind of coming down and shooting off to the right. So that's what I have going down. Coming down, shooting off to the right, like this. Domain is going to be 3 to infinity. Range, negative infinity to infinity. Okay, let's see what happens on this next example. Not Stilla. It's now a base 3. That's new. Not really new, but base 3. This is with the x, so it's a horizontal reflection. So it's going to reflect over the horizontal, so over the y-axis, I should say. Then it's going to go down 3. So again, I like to put the original in there when I start having a lot of stuff going on. It is a base 3, so that means 3, 1, 9, 2. Just thinking of the exponential backwards when I do that. And then I know that this is kind of coming up and going off this way. Now what I'm going to do is my horizontal reflection. So this point right here is going to reflect over to there, and then it's going to go down 3. This is going to reflect over, down 3. Reflect over, down 3. So I'm going to do that with each one of them, put it in red, get it graphed. Reflect and down 3. Reflect, down 3. Reflect, down 3. The reflection does not necessarily do anything, reflecting horizontally doesn't do anything to my asymptote, nor does the down 3. So the asymptote is really still right here, and it's going to look like this right here. Okay, domain is going to be restricted by that vertical asymptote, but because it reflected, it's now a negative infinity, and the limitation is on the right-hand side. It goes to 0. The range, negative infinity to infinity. All right, so I've done lots of examples. Hopefully you got the hang of it. If not, watch that again, practice some more. I just wanted a quick summary page. Just so that you recognize, I feel like once you start mixing these together, you lose track of what the general shape of an exponential versus a log is. So keeping in mind that exponential graphs always have like this horizontal asymptote, and they're going to be, oops, where'd that go? And they're going to be approaching that asymptote on the left and the right and shooting upward or downward. So that means it's going to kind of like being close this way, but it's going to shoot up. Even if you have decay, decay would look like that. Even if it reflects, it's going to be like shooting away from that asymptote. So, oh, and the other thing, I don't know if you want to put the key point on these. Of course, that key point can shift, but it generally is at, if you want to put it in here, you're welcome to do that. Your key point is going to be over 0, up 1. Okay, the logarithmic graphs are different. The key point is at 1, 0. And these graphs will always have a vertical asymptote. So you're going to have some sort of vertical asymptote that you're going to be approaching upward or downward. You're going to be close to the, and then you're going to shoot off to the side. You're shooting away from the asymptote, and you're going to shoot left or right. It might reflect or something, but you're always shooting off away from the asymptote after you've hit that key point. I don't know, just some things to try to help. All right, now that we've done hopefully you've done some exponential graphs, jump in there and do some logarithmic graphs. And then after you've done some of those, I mix it up and throw them both at you at the same time. Now can you keep track of which scenario is which? All right, good luck. Hope this helped.